Car travel. Most people use it every day, on their way to school, on their way to work, and just getting from point A to point B. In America, the country's infrastructure is built upon the automobile to get people where they want to go and cargo where it needs to be. The first automobile to become ubiquitous in society was the Ford Model T. Designed by the innovative Henry Ford, this vehicle made popular the gasoline combustion engine to power motor vehicles.
Combustion engines work by controlling small, timed explosions fueled by gasoline. Gasoline is compressed by a piston, and then the explosion pushes the piston back, and this action repeats over and over again for all the cylinders in the engine. This oscillating motion rotates a crankshaft that is geared to eventually turn the wheels and power the car. The combustion engine was a marvel of engineering that revolutionized the way people traveled for the past 100 years. However, today scientists have found that people cannot power automobiles with combustion engines forever. Gasoline is a non-renewable resource, and burning it releases greenhouse gases like carbon dioxide.
Carbon dioxide concentrations in the air have risen drastically over the past 50 years due to the exhaust emissions produced by fossil fuel burning combustion engines. This problem will only worsen as time goes on. As the world population increases, so does the amount of vehicles, which will continue to raise the concentration of CO2 unless something is done to curb the burning of fossil fuels. In order to reduce emissions, engineers have been working to design new engines and motors to reduce the need for fossil fuels. While not achievable yet, the ultimate goal would be to design a 100% emissions-free vehicle that has the same practicality as gasoline-powered vehicles.
One kind of engine configuration that has been heavily used as an alternative to the combustion engine is the combustion electric hybrid. In these cars, a combustion engine is supplemented with an electric motor to assist in powering the car. There are a few different types of hybrid configurations, but the parallel hybrid has been by far the most popular. One prevalent example of this type of hybrid is the Toyota Prius. Parallel hybrids operate by utilizing both a gasoline combustion engine and an electric motor, each of which activates independently and separately. This configuration allows for low demand acceleration and moderate constant speeds to be provided by the electric motor, and the gasoline engine provides more power for high speeds, high acceleration, and uphill drives. The electric motor also charges the battery during braking. The constant switching between different power plants is bad for the efficiency during stop-and-go traffic, as the gasoline engine must kick in regularly.
There is another type of hybrid engine that is prevalent in society, yet you may not know about it because it is not used regularly in automobiles. Yes, many trains use another type of hybrid engine, the series hybrid. These vehicles operate by using a gasoline engine as a generator to power an electric motor that moves the vehicle. The lack of a gasoline engine attached to the wheels means there is no need for an inefficient transmission to convert the combustion engine's rotating crankshaft to wheel rotation. Gasoline engines need transmissions for two reasons. Reason 1. Gasoline engines have only a certain range of functioning RPMs. The engine will explode if its crankshaft goes beyond a certain speed. Therefore, it must change gears if it wants to increase or decrease speed and stay within the functioning RPMs. Reason 2. Gasoline engines have a narrow RPM range where they make the most power and torque. Transmissions try to keep the engines in this range so that the vehicle will move most efficiently.
Electric motors do not need transmissions because they do not need to build up rotational energy to get a peak torque or power level. They can generate peak power or torque immediately. Electric motors also have no spinning parts, so they do not have a maximum RPM level. The gasoline engine operates at optimal RPM to power the electric motor, providing optimum power, and the electric motor generates torque immediately, perfect for stop-and-go traffic situations. Some vehicles that use series-powered engines are city buses because they excel in stop-and-go conditions.
A production car recently introduced to the market and similar to a series hybrid is the new Chevy Volt. The Volt does not solely use series hybrid technology, but also has a battery that can power the car. True series hybrids, like diesel-electric trains, continuously run the diesel engine to provide immediate power to the electric drive motors. The battery's purpose is starting the motor with stored electric energy rather than fossil fuel, increasing efficiency. True series hybrid vehicle would do the same. The Chevy Volt is not a true series hybrid because it can function as a totally electric car, and the series hybrid engine kicks in after so many miles.
The series hybrid car does not completely take humanity to the goal of 100% efficiency, but it could be a step in the right direction. If series hybrid cars are implemented in certain city, stop-and-go applications, then that could improve automobile efficiency now, and humanity could continue to use this technology just until a time where we discover a practical solution that is completely greenhouse gas free. Understanding the importance of new innovations in automotive technology and being aware of the impact automobiles have had on all species of the planet is something we can all do to play our part.